Good morning, guys. Today we're going to be going over the continuation of the engineering design process, and we'll be talking about creating the solution for your problem. So, on yesterday, we went over how to brainstorm these ideas and what to come up with, how to come up with a whole bunch of ideas on how to solve the problem. So now we're going to start to evaluate all of those ideas and start, sketching them out, sketching out, a few of the better or stronger performing designs and start refining those to figure out which ones we actually want to start designing, developing, and prototyping so that we can start communicating our ideas and our solutions to the managers and to the client. So in order to evaluate these designs, you have all of these ideas. So you've thrown, like spaghetti at the wall, 30 or 40 ideas for how this problem could actually be solved with your team. Now you're going to start Xing off the ones that you don't make a lot of sense. So although I've said there's no stupid ideas in the brainstorming phase, there are some impractical ideas. But the reason why we throw all of those ideas at the wall again is because your impractical idea might lead somebody to think of something practical that can be done because of that idea that you were holding in to think that was stupid. But now we have all the practical and impractical ideas on the wall. We start putting them together and we're coming up with three rough designs, ideas for how we're going to move forward and approach the solution. So these are the three practical ideas that we're going to move forward with. And now we start to put those ideas in competition with each other before we start moving on one idea in particular. So in order to do that, you take the constraints and the wants and desires from the problem statement and you list them as criteria. You also list them in order of what is most important for the client or your manager in order for them to purchase the product. And here you see that appearance is the most important, followed by cost, function, productivity, production, and safety. That's just an example. It's not always the case. This is just for this example. They also had their three designs. So as you can see, they've rated each criteria on a scale from 1 to 10 individually. So for design 1, it shows that it's the best looking one. Then they moved on to cost. On the cost side, the fact that it's rated as a 2, it's probably it's the most expensive, probably because with the appearance, they probably did some things that cost more to design, like rounded curves and particular finishes for the metal or something, depending on what it is. And then you move on to function, how easy it is to produce, and then the safety. So from there, they add them all up and you get a score. And from the scores, you can see that design number 3 ranks the highest. So one of the great things about doing this is it becomes an analytical discussion as opposed to one person, just being overbearing, trying to prove that their idea is the best. It's you have to prove that yours is the nicest. You have to also prove that yours is the most cost efficient. And so on and so forth. That way, like I said, you don't end up with that one person who just wants their design to win off of ego, because they're, may just simply be the bully of the group. And we've all worked in groups like that where there's somebody either, a mean bully or extremely charismatic that can just get people to do the things they want. And you end up with design number 1 because it was theirs, as opposed to design number 3, which will be the best for the company. So from there, you're going to communicate the solutions. The way you communicate the solutions is through, drawings and the computer generated solutions. So with the drawings, it's similar to what you all did in engineering design and presentation 1, where it's the 2D sketches. So those are great for manufacturing and it's great for your management, people that really fully understand all the aspects of it. But the computer generated solutions with the 3D modeling software allows anybody to understand and be able to see what you are working with. And a lot of times these are better for your clients, especially if your client isn't an actual engineer. It's better to be able to see what the design will look like in real life. Then we're going on to testing and analysis. So they approve the design. They like, what it looks like on paper. So now you start to make sure that it can work in the real world. So as I told you all when I was at Schlumberger, one of the things that we did was take the projects that I built over to that facility so that the testing engineers could, see when it was going to fail, when it was going to break, slamming it, vibrations, heat, and all of that. But before I even got to that stage, we would do computer simulation. So we had software that would run those same tests on the 3D models that I created in the 3D software. And it would test, figure out where would this break if it was under stress. At what point will parts of this fail if it's heated up to a certain point. So I would do all of that on the simulation first so that I could figure out if I needed to change the material or change the thickness in a certain area to prevent failure. And then we would go to the testing facility after they've been built to figure out if my calculations, my design, and the simulations held up to a real world environment. The other thing we did was rapid prototyping. So as I said, with the production on the criteria, sometimes what you design may feel like, okay, everything will work. And then you do the rapid prototyping, you get a couple of parts together, you start trying to put them together, and you realize, okay, this doesn't really make a lot of sense. We're not going to be able to put this together efficiently. So rapid prototyping came into play where we had a large 3D printer in the office, and I could just print the products that I was designing, and I could take them to the office. We could move them around. We could play with them in our conference team meetings, and get a feel for it on a cheaper plastic level before spending a lot of money getting this manufactured by a manufacturing shop. It also reduced the time, so you could actually get it, physically see it, see how the pieces were made together, see how things would work. Because a lot of these machine shops could take weeks to get things done, whereas with the rapid prototyping, I could have a printout sometime in the afternoon of what I was trying to test, and I could figure out what was going on from there. And again, it's like the computer simulations and going before testing. It's figuring out all these problems quickly and cheaply before spending tons of money on materials and labor to have these things manufactured. And then, as I said, as you're going through those processes, as you're going through this entire engineering process that we're discussing, you will always end up going back to different steps of the process to improve. Even when you have a product out there, you're selling it and it's working, you will always still come back and have iterations and have problems to improve the product. So the final solution is the mechanical drawings, the spec sheets for the manufacturers, and then that's what you actually send to management to sign off on, and to the client to sign off on and say, okay, here's what we like this is what we're going to use to go into production. So at this time, make sure that you answer the attendance question and answer the discussion question that follows.